Your review covers sections 1.8, 2.1, 2.2, and 2.3, which are the sections that are on your test. It starts with identifying this information from these graphs. So you're going to be given a graph. You're going to be asked for your domain, your range, your increase, your decrease, and your constant. Your domain is your x values that are covered by the line that's drawn on that graph. Your range are the y values that are covered by the line that's drawn on that graph. Your increase from left to right, you're looking at this graph. Wherever those lines go up from left to right, you're giving the x values for that increase. For the decrease, wherever the line goes down from left to right, again, you are looking at the x values from which that happens and giving those. Your constant, whenever it's a horizontal, straight horizontal line, the x values in which that happens is what you'll give for your constant. So if we look at number 1, it tells us to find those things. So the first thing we're going to look at is your domain. If we look at your domain, it's the x value. So from where to where, lowest to highest value, that your x values are. If we highlight here, hold on, let's do it this way. Your x values are being covered from here all the way up to here. So you get those x values. So we start at -1, 2, 3, 4, 5, 6, 7, -7. That should be -7. And then we go all the way to 1, 2, 3, 4, 5, 6, 7, 8, 9. We look at that ordered pair at the -7 for the x value, and it's a closed circle. So that's going to get the bracket. We look at the ordered pair on the 9, where x is 9. And that's an open circle, so that 9 is going to get parentheses. For your range, that's your y values that are being covered. So the highest y value is here, all the way to the lowest y value, which is here. So all of these y values are being covered by the line that's drawn on your graph. So the highest and the lowest there, and then corresponding with the ordered pairs. So your lowest is at -3. Your highest, 2, 3, 4, 5, 6 is at 7. So that -3 will go down first. We have a closed circle there, so that's going to get a bracket. That 7 would go down last since it's bigger than the -3. And that would get the parentheses since the ordered pair is an open circle. Next, we are looking at increase. Your increase is from left to right where that line goes up from. So we have 2 parts here where that line goes up. The one on the left, the x values that are being covered by the part of the line that goes up from left to right are -1, 2, 3, 4, -4 to -2. So those are both closed circles. They both get brackets. And then we also have from the 1, 2, 3, 4, 5, 6 to the 9. So that 6 has a closed circle on it, it's going to get a bracket. The 9 has an open circle, it gets a parentheses. For your decrease, that's where the line goes down from left to right. So that's here and here. Again, you're taking the x values of those. So we have that -7 to -4. Those both have closed circles, so we put brackets around them. Then we have from 1, 2, 3 to 6. And again, both closed circles, so those get brackets. Next, the only thing that we have left over is our constant. So that's that horizontal part that goes side to side, that's straight. So that's going from the x value of -2 to 3. And again, those are both closed circles, so those get brackets. For number 2, we have this graph that has arrows on the top and the bottom of it, or to the right and the left of it, which means as it goes up, it continues to go to the left. As it goes down, it continues to go to the right. So our domain and our range for this are automatically all real numbers. So domain goes from the far left to the far right, so from negative infinity to positive infinity. Your range goes from the really low down to the really high up, so that's from negative infinity to positive infinity. For your increase, that's where the line goes up from left to right. So you're going up from left to right here, and we take those x values. So the x values, -1, -2, -3 to 1, 2, 3. So those are just from -3 to +3. Now there's no ordered pairs there, so it's assumed that they are included, so that we get brackets on those. For your decrease, it's where the line goes down from left to right. So that's going from the negative infinity x value up to that -3. So from negative infinity to -3. With a union of where that 3 is to positive infinity, because we're going all the way to the right. So it goes to positive infinity, starts at that 3. So that's with 3 to positive infinity. Parentheses goes on the positive infinity. For this one, there is no constant on it, so you would write none. So there's no part where you have a horizontal line that goes straight side to side. If we look at the next one, it tells us that the graph of a function is given. You're finding f of something, and then you are finding over with those graphs. So with this graph, your domain, let's just find your domain range, increase, decrease, and constant first. For the domain, those are the x values that are being covered. So this goes from -4 to +2, picks back up at +2, and goes to +4. So that means that your domain is from -4 to +4. Your range, let's do this in a different color. Range are the y values that are being covered. So lowest y value is at 0, highest y value is at this 5. So you look here, you have 2 ordered pairs at that 5. You have one that's open, one that's closed. The closed includes the 5, so you're going to include it. So it goes from 0 to 5. Your increase is where the line goes up from left to right. So it goes up from left to right here. And that's the only area that it goes up. So that's from 0 to 2. The 5 has the bracket on the range because there's 2 ordered pairs at the y value of 5. One that's open, one that's closed. So the closed includes it, so that's why we put the bracket on it. If they were both open, then there would be a parentheses on the 5. For your decrease, you have 2 parts of this line, or these lines, that are going down from left to right. One that's here, and the other that's here. So that means that you are going down from -4 to 0. And you are also going down from 2 to 4. Now that 2 has an open circle on it for the part that's going down. So that one gets the parenthesis. And then you have the 4. That gets the bracket. Your constant is none, because there's no part of these lines that go flat side to side. If we are looking at f of -4 and f of 2, when x is -4, your ordered pair is here, and that is the ordered pair -4, 5. So the y value from that is your answer, so that would be 5. For the ordered pair that has 2 in your x value, you have 2 answers here. because you have this point here and you have this point here. So one is 2, 3, the other is 2, 5. You would include both of them.
I don't understand what the F of -4 is asking.
The f of -4 and the f of 2 is asking, what is your y value when x is -4? What is your y value when x is 2? So the f of 2, like we said, there's 2 of them. We would include both of them, so it would just be 3 and 5. With the -4, though, there's only one ordered pair with the x value of -4, so we just give that 5. For number 4, this one's a little different. You have a line that's going from -infinity up to, where is this? -1, 2, 3, -3 for your x's. The y on that is 1, 2, 3, 4, 5. Okay. Then you have another line that looks like that upside down V that goes from -2 to +1, which that 1 is there for you. Then you have another line for your x, or sorry, with that upside down V, it goes from -1 to from your y to -3 on your y. Then with the last line to the far left, that starts at the x value of 3, goes to 5, starts at the y value of 0, goes to -2. Okay, I'm not sure if that may confuse you a little bit, but I just put my x's and my y's for each of these lines, so that way it's a little bit easier for me to see my domain, my range, and all that kind of stuff. So if we state our domain from this, I'm going from -infinity to -3. From -3, it picks back up at -2, goes to +1. Stops at +1, then picks back up at 3, goes to 5. So I'm looking at my x values here that are being covered. So from the far left line, you're going from -infinity up to -3 with an open circle, so that -3 gets parentheses. You have another line that starts at -2 for your x values, goes to +1. Close circles on both of those, so those get brackets. Then you have another line that goes from 3 to 5 with your x values. Close circle on the 3, so bracket on the 3, open circle on the 5, so parentheses on the 5. From here, look at your x or your y values for your range. For your range, y values, lowest to highest, you have from -3 up to -1 with that lowest, that upside down V. -3
Do we have to do more
is
than
bracket.
just put a -3 and then 5?
Because so the reason why you can't just do like -3 to 5 is because it doesn't connect all the way through. If it connected all the way through where these lines overlapped, then you'd be able to do that. But because these like stop at a y value, then pick up at another y value, keep going for a little bit, then stop and then connect up again, that's why you'd have to separate it into parts.
So did you say for the third question, you said -4 is because 2, it's connected at 2 over there?
For which one?
For the question number 3.
For question 3.
For the domain, the reason why I'm saying is went from -4 to 4.
Because those two lines actually stopped and started at the same x value. So those two are like fluently through. With 4, that's not the case. I mean, that is the case for your bottom line and that line, like the middle one, and the line to the right. Because those two share the same y values. But then the one all the way up top doesn't. So you can include the two, like the one from the middle and the one from the right with the y values that go from -3 up to 0. Because it continues, that one on the right continues that y values, those y values we covered. So we're going to put this -3 to 0, close circles on both of those, so brackets on both, with a union of where that other line is. That other line is at 5. That 5 is going to go in parentheses because there's an open circle on it. There's nothing else above that 5 or below that 5 that is involved with that line to the left. So that's why it's just the 5. And again, since it's an open circle on the 5, there's parentheses on both sides of it. From here, we're going to look at increase. So your increase is where the line goes up from left to right. So up from left to right is here. So what are the x values that are covered when the line goes up from left to right? This x value is -2, this is -1. So that's just from -2 to -1. And then brackets on both of those.
Can you explain the 5 thing one more time?
The 5, because it's in the parentheses, is because it's a solid line, straight line that goes side to side. There's no other y values that are being covered from that line.
Okay.
And the reason why it gets parentheses on it is because it's an open circle.
Yeah.
Could you explain the range from -3 to 0?
The range from -3 to 0 is saying from -3 to here, and then your other line to the right goes to 0.
Well, why wouldn't we just do a union of the two? Because they're not connected.
Because there's fluency there.
Okay.
So the whole idea is for you to see every y value that's covered. So right now, all of those y values are just the 5, and then from 0 to, it's like saying 0 to -2, and then also, here, let's do this. Let's erase.
Why were you able to put those two together?
I can't do that. What two? These two lines? Okay. So if I was to highlight just this one, it would be here, right? If I was to highlight my other one, it would be here. They overlap. So it continues. It's kind of like when you were graphing your inequalities on a number line, when it was an and statement and those two lines overlapped. You really darkened it and you only had one line. And you got rid of anything else that extended past that part. So it's the same, it's kind of like the same concept. So like if they overlap, you don't need to like take it as 2. It's one x, or it's one y value.
Would it be wrong?
And the 5 is by itself.
Would it be wrong if you put them like separately?
It's not necessarily wrong, but like if you were, so here, if you were doing a union of these, this one in the middle is, we said, from -1 to -3, right? It includes those numbers. If you're doing a union with that and 0, or sorry, it should be -3 to -1. -3 to -1 with a union from -2 to 0, right? If you're writing a union of these, it means that it's what's included from both. What's all of it? The lowest part is the -3, highest part is the 0, because the numbers from the -3, -2, -1, some of those are included in the -2, -1, and 0. So you would just write it as 1. Okay. All right, so looking back at your increase, decrease, and constant. So your increase, we said, is from -2 to -1 because it's going up from left to right, and the x values in which it goes up from left to right are the -2 to -1. Then we look at your decrease. So where is it going down from left to right, and what are the x values? Well, it goes down from left to right here and here. So the x values in which that happens are -1 to +1 and 3 to 5. So your decrease is from -1 to 1, brackets on both of those, with a union from 3, bracket, to 5, parentheses, because the 5 has an open circle on it. I know it's really little, but it is open. So the only thing else that we need here is your constant, and your constant, I'm going to put here, is at what? -3 to infinity. It's the part that goes horizontally. So this part here, and we said that that goes to infinity, or sorry, negative infinity, and it starts at -3. So the lowest number there is negative infinity. Highest number is -3. That negative 3 has an open circle on it, so it gets parentheses. From here, we're just finding f of 0 and f of 5. So f of 0 is going to be where is the ordered pair when x is 0. That's here. That's the ordered pair 0, negative 2. So f of 0 is negative 2. Then we have f of 5. So what is the ordered pair when x is 5? That's the ordered pair 5 or negative 2. So the y when x is 5 is negative 2. For the domain, range, increase, decrease, and constant. So I'm just going to put those. This part, you are graphing the piecewise function. For number 5, you have f of x is equal to negative 2 when x is less than negative 3. F of x is equal to 1/2 x plus 4 if negative 2 is less than or equal to x, which is less than 3. Then you have negative 3x minus 2 when x is greater than or equal to 3. I'm going to start with the first one. The first one that we have is that negative 2 when x is less than negative 3. We are going to have an open circle where x is negative 3 because it's not also equal to. This is just a solid horizontal line at negative 2. So our y is going to be negative 2, our x is negative 3, open circle, and that line is going to go straight to the left because our x values that are being covered are less than negative 3. From here, we have 1/2 x plus 4 if negative 2 is less than or equal to x, which is less than 3. So if we were to draw ourselves a function table and find these values, you have x that's going to be negative 2, negative 1, 0, 1, 2, and 3. Those are the numbers that are from negative 2 to 3 and the ones between them. You're doing 1/2 x plus 4 and finding your y. So if you plug the negative 2 in there, you have 1/2 times negative 2 plus 4. The 1/2 times negative 2 is negative 1. Negative 1 plus 4 is 3. You only need 2 points in order to draw the line, but I'm going to use the numbers that work best with the 1/2. I don't want to work with the fraction, so I'm going to work with numbers that get rid of my fraction. If I use 0 next, I'm going to have 1/2 times 0 plus 4, which is 0 plus 4, that's 4. Then if I use the positive 2, that's 1/2 times 2, which is positive 1, plus 4 is 5. Now 3 is the last number in my inequality, which means I have to use that one. So that's going to give me 3 times 1/2, which is 3 over 2, plus 4, which is 8 over 2. So 8 plus 3 is 11 over 2. That's going to be 5 and 1/2. So if we go to graph these ordered pairs, we're going to have a closed circle on the negative 2, 3, an open circle on the 3, 5 and 1/2. So negative 2, 3, 1, 2, up 1, 2, 3, closed circle here. Then we have the 0, 4, which is here. And then we have the 3 and 5 and 1/2. So over 3, up 1, 2, 3, 4, 5 and 1/2. So that's going to be about here. So our line is going to go between these points, and that's it. Last one that we have is the negative 3x minus 2 when x is greater than or equal to 3. So we're going to use the 3, and I'm going to do 4 and 5 just to get myself a little bit of a line going. I'm going to plug that into negative 3x plus 2. So that's negative 3 times 3 plus 2. That's going to give me negative 9 plus 2, which is negative 7. Then I have negative 3 times 4, which is negative 12, plus 2 is 10. Negative 10, sorry. Negative 10. Then negative 3 times 5, which is negative 15, plus 2 is negative 13. That one's not going to fit on my graph. So I'm going to start at the negative 3, 7. We have a closed circle on that since it's greater than or equal to. So negative 3, 7, or sorry, positive 3, 7. So 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7. So we said closed circle there. From there, we're going to do 4, negative 10. So I'm going to go over to the right one more and then down 3 to get this point here. When I do this or draw this line, I'm just going to put an arrow at the end of it to keep short, or to make sure that my line just keeps going down and to the right. So those are the 3 lines represented by the 3 functions in our piecewise function. Your function actually is -2. So this is going to be -2, which means this is -2, this is -2, this is -2. So these are going to change. Which means this is going to change. Okay, so if we do the -2, -3 times -3 is -9, -2 is -11. That doesn't even fit on our graph. The -3 times 4 is -12, -2 is -14. -3 times 5 is -15, -2 is -17. So we are going to be 3, -11, which is going to be about, let's say here. Then 4, -14 is about here, so our line is going to be off the graph and kind of look like this. So if I skip the number 6, the piecewise function 1, for 7 through 10, it asks you to state the domain of the following using interval notation. With your domain, if it is just x to a power, not in the denominator, not under a radical, it's automatically all real numbers. So like for number 10, you have f of x is equal to 4x cubed minus 5x squared minus 17x plus 1. X is not in the denominator, it's not under a radical, so automatically it's all real numbers. So that would go from -infinity to positive infinity. Automatically. Those are the easiest ones with this.
Why is it like that?
That's because your x doesn't have anything like wrong with it. It's not in the denominator of a fraction, it's not under a radical. So if it's not in the denominator of a fraction or if it's not under a radical, automatically all real numbers. Now, if your x is in the denominator, you're going to take the denominator, set it not equal to 0, and solve. So like in number 7, you have f of x is equal to x squared minus 9 over 9x squared plus 7x minus 2. You have an x in the denominator here, so you're going to take this whole denominator, set it not equal to 0, and solve for what x can't be. So this 9x squared plus 7x minus 2 cannot equal 0. Your a is not 1, so we're going to multiply 9 times -2. That's -18. You want the factors of -18 that add up to be 7. You have 1 and 18, 2 and 9. It's a negative. If your 2 is negative and your 9 is positive, that gives you 7. So if we rewrite this to give you 9x squared minus 2x plus 9x minus 2 is not equal to 9, we can solve this, or we can factor this by grouping. We're going to group the first, group the last two, factor out an x from the first, factor out a 1 from the second. So that gives us x times 9x minus 2 plus 1 times 9x minus 2 is not equal to 0. Parentheses are the same, so that's 9x minus 2 times x plus 1 is not equal to 0. Set them both not equal to 0 and solve. For the 9x minus 2 is equal to 0, you would add your 2 over, then divide each side by the 9, so you would get that x cannot equal 2 over 9. For your x plus 1 is equal to 0, you would just subtract the 1 over, so x cannot equal -1. This is interval notation, so think about this on a number line. Your -1 is less than the 2/9, so on a number line, if you had from -infinity to positive infinity, you would erase out the -1 and you would erase out the 2/9, which means for interval notation, you would be going from -infinity to -1, not including the -1, so parentheses, with a union from -1 to 2/9, not including either of those, so parentheses on both of those, with a union from 2/9 to infinity. So ultimately, since it asks you for interval notation, this is your answer. Okay, that's if x is in the denominator. You're not necessarily going to have to factor like this every single time if x is in the denominator. It just depends on what is in the denominator. Now, you could also have x under a radical. If you're stating the domain when x is under the radical, you're going to take the part that's under the radical and only the part under the radical and set it greater than or equal to 0. So in 8, you have g of x is equal to the square root of 6x plus 5. Your 6x plus 5 is what's important here because it's under the radical. Then it's got the minus 7. Minus 7 is irrelevant, does not matter. So you're going to take the 6x plus 5, set it greater than or equal to 0. Solve. Move your 5 over, subtract it to both sides. You get 6x is greater than or equal to negative 5. Then divide each side by the 6. It's positive, so you don't have to flip the sign. That's x is greater than or equal to negative 5 over 6. If you were to graph this on a number line, you'd find your negative 5 over 6. Close circle on that. Line would go to the right. So the interval notation for this would be from negative 5 over 6 to positive infinity.
Why did you put greater than?
Because you can have a number that's positive or 0 under the square root. So that's why we use the greater than or equal to. Now, if that square root has x under it and it's in the denominator of a fraction, you can't have 0 as a denominator. So that's when we would just set it greater than 0. So like in number 9, you have h of x is equal to 2x squared minus 8 over the square root of negative 2x plus 5. That whole thing, that negative 2x plus 5, since it's under the radical and it's in the denominator, you're going to take that and just set that part greater than 0. Because again, you cannot have 0 in the denominator. It can't be equal to it. So we have negative 2x plus 5 is greater than 0. Move your 5 over by subtracting it from both sides. That's negative 2x is greater than 5, or negative 5, sorry. Then you divide each side by the negative 2. When we divide by a negative, you flip the sign. So x is less than positive 5 over 2. To graph this, you're going to have an open circle at 5 over 2, and your line is going to go to the left, which means the interval notation is from negative infinity to 5 over 2 with parentheses on the 5 over 2. Your review that you may see on your test tomorrow does deal with piecewise functions. However, it's a little different than graphing them. So if we look at number 6, just for the piecewise function, the f of x is equal to negative x squared plus 3 when x is less than or equal to negative 1. F of x is equal to 2 over 2. Let's try that. Let's switch that to 2 over 3. X minus 2 when negative 1 is less than x, which is less than 3. And then f of x is equal to negative 4 if x is greater than or equal to 3. If you are evaluating these, you're going to be told to find f of, let's say, negative 4. You're going to be told to find f of 0. And you're going to be told to find something like f of 12. Okay? So if that's the case, I'm going to just, like I said, move these over a little bit. For f of negative 4. Negative 4, is it less than or equal to negative 1? Yes. So you are going to use f of x is equal to the opposite of x squared plus 3. Plug the negative 4 in for x and solve it. So f of negative 4 is equal to the opposite of negative 4 squared plus 3. The negative 4 squared gives us 16, so that's the opposite of 16 plus 3. The opposite of 16 is negative 16 plus 3 gives us f of negative 4 is equal to negative 13. Okay. If then we find f of 0, that means that you're going to plug that 0 in for those inequalities. is 0 less than or equal to -1? 0 is less than or equal to -1? Nope. Can't use that top one. Is -1 less than 0, which is less than 3? Yep. So we will use f of x. We said that it's 2 over 3x minus 2. And we're just going to plug that 0 in for that x. So f of 0 is going to be 2 over 3 times 0 minus 2. 2 over 3 times 0 is 0. Minus 2 is -2. So f of 0 is -2. From here, if we do f of 12, f of 12, we got to try out our inequalities. So we're going to have 12 is less than or equal to -1. Is that true? Nope. So can't use that one. -1 is less than 12, which is less than 3. Is that true? No, can't use that one. The bottom one is 12 greater than or equal to 3. Yes. So you are going to use f of x is equal to -4. Plug in that 12 for x. That's just f of 12 is equal to -4. For the last part of your review, it asks if the equation defines y as a function of x. Why or why not? Your why or why not is whether or not x is inside the absolute value or y. Y cannot be inside the absolute value. Y cannot be raised to an even power. So look at the power on y. Look at where y is. For number 11, you have y to the 4th power plus 7x is equal to -1. I'm going to circle this power on this y because it's an even power. So is this a function? No. And again, it's because that y has a power of an even number. For number 12, you have y cubed minus the absolute value of x minus 9 is equal to -5. That y is not inside the absolute value. It's not raised to an even power. So this is a function. For 13, you have 2x squared minus 13x plus y is equal to 17. Your y is not inside the absolute value. Your y is not raised to an even power, so this one is a function as well. For 14, you have -9 times the absolute value of x minus 5y plus 7 is equal to 8. Your y is inside the absolute value here, so this one is not a function. Just put no. So what's not